if I actually applied Ito's lemma to that whole thing, I would have gotten dx equals delta c. This is just a transform, okay? So I'm going to build the tree on this one because, as you're going to see very shortly, things are a lot more convenient. This process X is simply a symmetric evolution of a symmetric normal distribution. Now, then delta X is basically a normal random variable with a mean of 0 and a standard deviation of square root of delta t. Okay. Now let's construct a tree. Let's start with the beginning. This is x0. Okay. I'm gonna make 3 moves. This is gonna be x middle, x upper, x lower. Okay. I'm gonna pick these. So this happens with probability PU. This happens with probability PL, and this happens with probability PM, but PU plus PM plus PL has to be 1. I made time period so small, only 3 things can happen. You can go up, you can stay in the middle, not necessarily equal, and you can go down. And they have different probabilities. But I want this little approximation. This is basically a discrete approximation to normal distribution. I want this approximation to share some properties with the actual normal distribution. I want this discrete random variable to have some properties that are the same as the normal zero distribution. So I won't expect, let's call this the discrete probable distribution. For the change, let's call that delta x hat. Okay. I want expected value of delta x hat to be the same as expected value of delta x. Okay. Now, if delta x is, remember, a normal distribution with mean 0, standard deviation of square root of delta t. So expected value of delta x is 0. Okay. It's a symmetric distribution that has a mean of 0. Now, this delta hat x is a discrete random variable such that it could be the movement up, okay, the movement middle, or the movement low. This is going to happen with probability PU, PM, and PL. Okay? So there are 6 things that we don't know, and we're going to impose conditions And from those, we're going to figure out what those 6 things should be. First of all, one of the conditions is PU plus PL plus PM equals 1. Okay? So if expected value of delta hat x is going to be U times PU plus M times PM plus L times PL, and that has to be 0. So that's one of the conditions. Since normal distribution is symmetrical, we must have PU equals PL and U equals negative L. It has to be symmetrical. I mean, if you're going up by 1 at the top, the down has to be negative 1. So we have 1, 2, 3 conditions already, and this immediately says U equals L, right? Or negative L. So this is UPU plus MPM plus or minus, in this case, UPU. Remember, PU has to be PL, right? And UL has to be negative U. Well, PM is positive, hence M must be 0. So the middle move for the X is staying constant. So we figured that out, okay? So M is 0. Next, we will impose that. Now we don't know only 2 things, okay? We need to know U and we need to know PU. Because if I know U, I know L, which is negative U. If I know PU, I know PL, which is PU, and PM is by definition 1 minus 2 times PU. So I need to solve 2 equations. We will impose that variance of delta x hat is equal to variance of delta x. Now, variance of delta x is precisely equal to delta t. Remember, variance is square of standard deviation. So variance of delta x, not x, x hat is PU times U squared. Remember, the mean is 0, so I don't have to worry about that. Plus PM times M squared plus PL times L squared. Well, PU times U squared. M is precisely 0. And PL is PU times L is negative U, that's U squared. So this says 2 times PU U squared needs to equal 1. Alright? Oh, not 1, I'm sorry. Delta T.